Hi, this is King of Review. Here we have an inequality to solve where we have the log base 0.5 of x squared minus 3 times the log base 0.5 of x. So right away I'm thinking I have this log squared and I have this log not squared. To make this problem simpler, I might want to introduce a variable, let's call it y, that simply means the log base 0.5 of x. The value of doing that is I can plug in y wherever I see a log 0.5 base 0.5 of x, and I can just call that y. So here I've just rewritten the inequality with y in place of the log, and this is a fairly simple quadratic inequality to solve, because I can try to factor the left side. I know that y times y is y squared, so I need two numbers that multiply to positive 2 and add up to negative 3. Well, negative 1 and negative 2 will do that. And if these two factors multiply to give me a negative number, that means one of them has to be positive and one of them has to be negative. Either the first one is positive and the second one is negative, or the other way around, the first factor is negative and the second factor is positive. If we solve each of these simple inequalities, we get y is greater than 1 and y is less than 2, or y is less than 1 and y is greater than 2. Well, let's look at these on a number line real fast. On the right side here, we want a number that's less than 1 and also greater than 2. But that's impossible. You can't be in both of those places at once. So this solution is not going to work for us. If we put the left side on a number line, we want to be greater than 1 and less than 2. That works. You can have a number that is greater than 1 and less than 2 at the same time. And here's how we can write that inequality. We can say 1 is less than y, which is less than 2. So, let's now turn this solution, 1 is less than y is less than 2, let's turn it back into x. We know that y is the same as the log base 0.5 of x. So now, to get x by itself, like we have in our answer choices, we just need to get this log out of here. And the way we do that is by remembering that logs and exponents are inverses. If we take a base b and raise it to the power of the log base b of some number x, b is now the base of an exponent and a log, and those two will cancel each other out, leaving us with just x. Since 0.5 is the base of my log, I need to take 0.5 and raise it to the power of 1, of log base 0.5 of x, and of 2. So I'm raising 0.5 to all three powers in this problem. 0.5 to the first power is just 0.5. Bring the less than sign down. 0.5 and the log base 0.5 cancel out, as in this property down here, and we're just left with x. And then on the right we have 0.5 squared, which would be 0.25. But I've actually made a mistake, a purposeful mistake in what I've done here. The trick in this problem, one of the big tricks, is that 0.5, the base, is less than 1. When you take a number less than 1 and you raise it to a higher exponent, you get a smaller number. As an example, we can see what happened. We had 0.5 to the first power is 0.5, 1/2. Over on the right, we took 0.5 to the power of 2, a larger power, and that gave us a smaller number. So, I actually have my signs backwards. When you raise 0.5 to a higher power, you get a smaller number, which means my signs are exactly opposite the way they should be. Now, normally we don't write compound inequalities with greater than signs, we write them with less than signs. So if we want to write them with less than signs, we have to flip the whole inequality around, put 0.25 on the left, put 0.5 on the right, and then all we need to do is change these decimals into their corresponding fractions, and we have our answer for x, which must be between 1/4 and 1/2. Thanks for watching.